Good evening, dear students. Right, okay, today we're supposed to start the paper number 4, MCU 4. Right, I think you can hear me clearly. Okay, then we'll start the discussion. Yes, in the paper, question number 1. Right. Can you all hear me clearly? Yeah, people? Yes. Okay, no? Right. Okay, then we'll start the discussion today. Right. Okay, the first question is question number 1, the logarithm part. Yeah, that question gives something like this. A, B and C positive real numbers excluding 1. This is what this means. From the set of positive real numbers, this 1 is removed. Then the rest positive real numbers only this ABC can take. That's the meaning of that. Okay, then ask him to show this. Okay, what is that? 1 upon 1 minus log A 1 upon BC plus 1 over 1 minus log B 1 over CA 1 over 1 minus log base C 1 upon AB. This way we are given. Yeah, we do it like this, right? This one first term we can write. People, I write this one like this. Log A to the base A minus log. This BC part, BC product, from here I take to numerator. Then that will be BC to the power minus 1. Here, base A. Similarly, I can write this 1 log B to the base B, because this is 1, no? Right. And minus log here B. CA I can take to numerator, C to the power minus 1, no? Like this. And 1 over log CC here minus log C AB to the power minus 1, like this. Okay. But now this minus 1 power you can take before. The reason is, you know, this formula we learned. Log m to the power r to the base a. This r we can bring before. R log am. Like this. Then I can take this minus 1 power before this. With this minus sign, all these 3 terms become positive, no? Yeah. So then I can write it like this. Log A plus log A BC, and here also log BB plus log B CA, and here log CC plus log CAB. You see, I can write. But next line, since here we have the same basis of log and log being added, then we can write this one how? Multiplying these numbers under log a. Then I can write it 1 over log base a, b, c product here. Here also the same thing I can write log base b, a, b, c product we get. 1 over log c, a, b, c product. Okay. Right, next one people, this log term we can take from this denominator to numerator. Then these two numbers exchange the places. That theory, you learned that, we learned that. We can change that. Taking these three log terms to numerator, you can write that like this. Log base now ABC number A. Taking this to numerator. Okay, that theory we learn, no? Yeah. And next one, log ABC B here, log ABC C here. Now again, sum of three log terms with the same base we have, no? Okay? With the same base we have. Then we can write this how people? Writing base ABC multiplying this three ABC. Okay. Then this is 1. When the number and the base being equal means this answer is 1. This answer is 1. Right? This is how we take the first answer. Right. I think most of you would take this answer. Right, no? Okay, now question number 2. Question number 2, partial fraction part. Partial fraction part. Question number 2, partial fraction part. Yes, find partial fraction of 2x of x minus 1, 2x minus 1. No? Number 2. 2x over x minus 1, 2x minus 1. Then how to write the partial fraction here? We have denominator non-repeating linear factors, no? Here we can write this as x minus 1. This is 2x minus 1. We write here a and here this is b. Now you can multiply this both sides by x minus 1 and 2x minus 1. Then we get 2x here. Then when I write this way here, this x minus 1 will cancel with this. We get like this. B times x minus 1 we get, no? We'll equate the x to the power 1 coefficient. Here we get 2a and here we get b. Here we have 2. Number 1. X to the power 0 coefficient. That means constants. We equate constants. Right? Once you get constants, here we get minus a, there minus b. Equals left hand side no constants. Right. So then this says a equals minus b. O minus b equals a. Then people by solving this 2. Now suppose here for this b, when you subject b here, we get minus a, no? When I put minus a, 2a minus a is a equals 2, then b equals minus 2, no? By 1 and 2, right? We get a 2, b minus 2. Okay. A equals to B minus 2. Then substituting here AB values here and here, we can write people partial fractions this way. 2x upon x minus 1, 2x minus 1, A 2 over x minus 1, B minus 2, no, here, minus 2 over 2x minus 1. This way, we can take the partial fraction. Okay. Now asking, hence obtain partial fractions of this. 2x upon x minus 1, x minus 2. Now, what I do to take the last answer is, in this answer, we replace x by x by 2. Replacing simple x by x by, understood. For simple x, we substitute x by 2. Simple x means any real number. Right? This equality holds people for any value of x. Left and right mean an identity. Identity. Identity means left and right are equal for any value of x. Right? So now, that is why we can replace x by any other expression in x. Because the both sides are equal for all real values of x. When x is a real number, left and right being equal, then x divided by 2 mean the other real number. Okay, therefore for x I can put any expression in x. In the sense, linear expression we can put. Right, others also we can, but here linear expressions only we are supposed to put. Right, so now substitute for every x, x by 2, then 2 times x by 2, x by 2 minus 1, here 2 over x by 2 minus 1, this way, right? We get. People, now this 2 we can cancel down this way. This 2 also we can cancel down. This 2 we can cancel down. Okay. Then here we can take the common denominator as 2. This becomes x minus 2 whole thing divided by 2, no? Yeah. X over x minus 2 whole thing divided by 2, this bracket. This is now x minus 1. Here 2 over x minus 2 divided by 2 minus 2 over x minus 1, like this. Now this 2 you can take where? Here. This 2 you can take where? Here. Right? Then what do you get? It is now 2x upon x minus 2, x minus 1. Here 4 over x minus 2 minus this way. Okay. Then we get the partial fraction of 2x over x minus 1 into x minus 2 is equal to 4 over x minus 2 minus 2 over x minus 1. This way we can take the partial fraction of that. Okay. Right. That's how we take that. Third one. Number 3, polynomial function lesson. Yes, fx given fx equals x cube plus ax squared plus bx plus c. It is given that x minus 1 squared is a factor of fx. X minus 1 squared is a factor of fx, right? And the graph of y equals fx cuts y-axis at 2. What is meant by this, people? The graph of fx. Now, you know, for any this way function, there is a corresponding graph, right? We are given, if we assume the graph is like this, people, for instance, right? We are given the graph cuts the y-axis at 2. This point is 2. So, the equation of this is y equals fx. So, what do you mean by this? This point, you know, x coordinate is 0, y coordinate is 2. That means, in this fx, if I put 0 for every x at these places, on the right hand side, for every x, if we put 0, the corresponding y value is this fx, no? The corresponding y value is what, people? 2. That's what this says. That means, when you put x equals 0, at these places, the same x only here we have, no? When you put x equals 0, f0 we get. f0 is 2. That's what we are given. Here this fx means y value. Fx means y value. Fx stands for y value. Then f0 is 2. That's what we are given. Right. f0 is 2. f0 is 2. That's what this says. Okay. f0 is 2. Right. Then we can write first one, put 0 for every x. Then we get f0. And then what do you get for when you put x equals 0? This is 0, this is 0, this is 0. Then we get c only. Put that here. C. f0 equals 2. Right. Okay. Secondly, given x minus 1 squared is a factor. X minus 1 squared is a factor of this, people. X minus 1 squared is a factor. That means I can write x cube plus ax squared plus bx plus c. This is fx. X minus 1 squared is a factor of this mean. I can write this fx. How? X minus 1 perfect squared multiplied by another function. I'll assume that function as 5x. Okay. This we can write. Reason? Given x minus 1 squared is a factor of fx. That's the reason. Okay. Now, we need to find 3 unknowns, no? A, B, C. C is already known. Then what I put here, people, we put x equals 1. Where? Here I will take this as star. Put x equals 1. When you put x equals 1, what do you get? 1 cube is 1. A into 1 squared is A. B into 1 is B. Plus C. C is 2. When you put x equals 1, 1 minus 1, 0. Then this is 0. Then whatever the 5x function, 0 multiplied by 5x is product 0. Understood? So therefore we get 0 there. Then you can subject A plus B. 1 plus 2 is 3. Take that right hand side, minus 3. Number 1. Another equation we need, people, to find A and B. To get the next equation, people, what we do is, we differentiate the star both sides with respect to x. Differentiate in star with respect to x. Right, this A, B, C constant. So then x cube derivative is 3x squared. Plus, here A is a constant. X squared derivative is 2x. 2ax. And B. Derivative of x is 1. C is a constant, right? Now this is differentiated. How, people? Taking this as u and this as v. Okay. Keep this x minus 1 squared as the same. 5x derivative is 5 dash x. And we have to keep as the same 5x. The derivative of this x minus 1 squared, bring this 2 before, x minus 1 to the power 2 minus 1, multiplied by the derivative within bracket. Okay? 2 times x minus 1. 2 times x minus 1, derivative of x minus 1 is 1. Now we put x equals 1 both sides. Put x equals 1. What do you get here? 1 squared is 1, 3. Plus 2a into 1 means 2a. Plus b. Again, people, when you put x minus 1, x equals 1, when you put x equals 1, this x minus 1 factor will be 0. Therefore, this product will be 0. Here also, x minus 1 will be 0 when you put x equals 1. This, again, the right hand side becomes 0. Right. Now, we get another equation. We get another equation. Okay. Then what do you get there? 2a plus b is equal to minus 3. Let us take that as equation number 2. Okay. And then first equation, a plus b equals minus 3. Number 1. Okay. Now, solving, we get the AB values. How? Take 2 minus 1. Here A, B minus B, 0, minus 3 when you subtract 0, A is 0. When A is 0, B equals minus 3. Right? Okay. We found ABC. Right. We found this ABC. Right? Now, hence write down fx in factors. Right. Then I can write, substituting for this, ABC. Right. X cube, A is 0, no? B minus 3. B minus 3. Minus 3 x. Right? Right. Then we get what? A is 0. X cube minus 3x plus C is 2, no? Correct, no? Right. Bx plus C. Right. B is minus 3, C is 2. Right. Correct. Then this is our fx. Right. We have been given x minus 1 perfect square is the factor of this. Then I can write it like this. X minus 1 squared is a factor given, no? So then once we remove the bracket here, we get second degree polynomial. This is third degree polynomial. Then of this fx, the next factor should be first degree polynomial. First degree polynomial factor I can write as x plus alpha. Then you might ask, can't we write it as ax plus b? Possible. I know here x cube coefficient is left hand side 1. Here when you remove the bracket, we get x squared minus 2x plus 1. That x squared. And here in the second bracket, x together will give x cube. Since x cube coefficient is 1, definitely this coefficient should be 1. So I directly put that as, therefore, without writing this as ax, directly x. And for the b, only I put alpha. Now I need to find this alpha. Okay? I need to find this alpha. Right? How to find alpha? Right. Put x equals 0, people. Then we get, right? What do you get there? When you put x equals 0, left hand side 2, right hand side minus 1 squared, alpha. Alpha should be what, people? 2, no? Minus 1 squared is 1, alpha 2. Then put that pair here. Therefore, we can write fx is this now, right? It is equal to x minus 1 perfect squared into x plus alpha is 2. You see. Okay, right. This is how we take the terms. Right, fourth one. Number 4. Right. Fourth one given. We are given ABC triangle. Be the vertices of a triangle ABC. Find the area of the triangle in terms of K. Right. We are given ABC triangle like this. Right. Point A is K3K. Point B 1, 2. Point C minus 3, 4. This is right. K 3K, B 1, 2, B 1, 2, C minus 3, minus 4. Right. You know, when you are given this way, the coordinates of the vertices, right? The coordinates of the vertices of triangle, you know, people, how to find the area. Yeah. We'll see that how to write. Yes, how to write that area? ABC area, we can write this way. ABC triangle area equal to half modulus. You know, we take this way, x coordinate of a vertex and rotate into same sense, say anticlockwise. Of the other two vertices, a difference of the y coordinates. We start from here keeping x coordinate k of the vertex A before a bracket. Now we move this way anticlockwise sense. We take the difference of the y coordinates of the other two vertices, 2 minus 4. And then we come to the vertex B, its x coordinate we keep like this, difference of y coordinates of the other two vertices rotate into anticlockwise, 4 minus 3k. Next one, at minus 3, we have to keep minus 3, right? 3k minus 2. This way, right? Okay. And now we can simplify this. ABC triangle area is equal to modulus. Here we get 2k, minus 3k is minus k, here minus 9k, minus 10k. Constants, right, sorry, I made a mistake, you know. Here we get really minus 2k, no? Minus 2k, minus 3k, minus 5k, and minus 9k. Then we get what people there? Minus 14k coming, no? Something like that, no? Correct, no? Here 2 minus 2 minus 4 is minus 2, minus 2k, minus 3k is minus 5k, and here minus 9k, minus 14k. And constants here, plus 4, plus 6, plus 10. This is what we get. Huh? This is what we get. Right. Okay, then correct now, people? Yeah, you can really take class 2 out from this modulus sign. Here, I can take 2 out. And this will be 5 minus 7k modulus ABC area. This and this you can cancel down. ABC area comes as modulus of 5 minus 7k. Right? So there we know the modulus we put because the area cannot be negative. Right? For this purpose only, we write that modulus sign. And right, now asking what people? Hence find the value of k for ABC area to be 10 units. Right? ABC area should be 10 units now. Right. First part. ABC area should be 10 units. Alright. But ABC area is equal to this. Modulus 5 minus 7k equals 10. Right. Then, you know, we can remove the modulus. Put in plus or minus to right hand side like this. Huh? Then we will take plus sign. If you take plus sign, we get 5 minus 7k equals 10. Take this right hand side, this side we get minus 5 equals 7k. K equals minus 5 over 7. Take minus sign. Once you take minus sign, people, we get 5 minus 7k equals minus 10. Then 15 equals 7k. K equals 15 over 7. These are the two values for k. Okay? Right. Secondly asking, second one, what are the value of k for the points A, B and C to be collinear? People, A, B, C, these 3 points should be collinear. When these 3 points become collinear, people, this point A should come onto this BC line. Then only this B, A, C collinear. Okay? This point A should come to the line BC. Then the 3 points will be on the same line called as collinear points. Once this point A comes to the BC line, this triangle will have 0 area. Right? Triangle will have 0 area. Understood? Triangle will have 0 area. Right? So therefore, when ABC collinear, collinear means they lie on the same line. Collinear, ABC triangle area equals 0. ABC triangle area equals 0, people. Right? Right. ABC area is this, no? Then we get, what is that? 5 minus 7k. Modulus should be equal to 0. For this, 5 minus 7k should be equal to 0. K equals 5 over 7. Right? Under this, it happens. Right. That is okay. Few questions finished. Right. Right. Applied maths question. Projectile. Right. Right. So we are given this way. The particle is projected with initial velocity v at an angle theta to the horizontal like this. Initial velocity v at an angle theta to the horizontal this way. Then the path come in like this, the trajectory. At the highest point O here, when the particle passes the maximum point, that means highest point on its path, its velocity is u. Right. You know, when the particle passes the highest point, its direction of motion is horizontal. We know that. That velocity given as u. And also, you know, this horizontal velocity of the particle, horizontal velocity component of the particle, is always equal to initial horizontal velocity component. You know this. Then initially, this direction velocity is v cos theta. Then we have v cos theta equals u. Right? Horizontal direction, always the velocity component of the particle during its motion is equal to horizontal velocity component of initial velocity v cos theta. Then v cos theta equals u. Then we can write cos theta u upon v. First thing is this. Secondly, people given when it moves at right angles to the initial direction of projection. Right angles to initial direction of projection, right? So this way, when I actually produce this line this way, right? This is initial direction. That direction it is at the moment. Right. Suppose the point this, when the particle passes, take that point as P. Right. Once the particle passes the point P on its path, right? This is the point P on the path. We are given its velocity is W. This is W. Velocity is W. Right? This is what we are given. Okay. Asking to show this answer. Right. We'll see how to take this. Right. Now I am going to assume the time taken by this particle, to reach the point P, I am going to assume as T. Right. Other thing is, now suppose here I draw vertical line here like this. Suppose here I draw vertical line. Along this vertical line, the acceleration due to gravity acts. Right. You know, if this is theta, since here 90, this is 90 minus theta. Since the whole angle is 90, this is theta, no? Correct, no? This is theta. Here 90 because this G is vertical. Therefore, this is 90 minus theta. And this is theta, right? Okay. Now what I do, I apply equation of motion this. I apply the equation of motion V equals U plus AT for the motion of the particle from O up to P. Usually in a question, projectile question, we apply the equation of motion horizontally and vertically, no. It is not a rule like that to apply. Along any direction you can apply equation of motion by considering certain part of the motion of the particle. Then my part of the motion of the particle is people from O to P. From O to, starting here, particle moving along this path up to here. That is my part of the motion. And considering that, I apply V equals U plus AT along this direction and this direction. If you apply like that, you get the answer very easily. All right. Now we can write applying V equals U plus AT. Right. First we apply along this direction. That means initial direction of projection. Here in this equation of motion, V means the final velocity. Final velocity means since our motion is from O to P is the motion. Then over there that V means when the particle reaches to the point P, at that point P, the velocity of this particle along this direction, because to this direction only we apply. That means if I apply, draw that direction here, this is the direction. That direction going to be perpendicular, right? Then this W has no component along that direction. Right? This U mean people, the horizontal velocity, yeah? Right. So then along this direction, no velocity. For what? For this V, 0. U means initial velocity of projection here, V. Right? Plus A should be acceleration. Right. See here. This is the direction we apply the equation of motion. This is the acceleration due to gravity. Its component we have this way. G, here, G cos 90 minus theta. G sin theta. It will be pointing in this direction, but we apply this direction. Therefore, it is minus G sin theta. Minus G sin theta times T. Then we can subject thereby the T. What we get? V over G sin theta. Right? Now, secondly, we apply the equation of motion this direction. Here 90. The same V equals U plus AT we apply. Okay. Then here V, final velocity. We apply this direction. That means when the particle is at the point P, along this direction the velocity, it is W, V, W. Right. People, initial velocity. When it is projected, the velocity along this direction. The velocity of the particle when it is projected, right? So initially it is projected this way. The direction we apply is perpendicular to this V, this way. Then this V has no component that direction. That's 0 now. That's 0 now. Acceleration A. What direction? This direction. That means along this direction. It is G cos theta. G cos theta. Times T. T you can subject. W over G cos theta. Okay. Now people, the same T, then this and this we can equate. Therefore we can write, right? V over G sin theta is equal to W over G cos theta. G and G you can cancel down. Bring this W here, sin theta here. Sin theta by cos theta is tan theta. Here we get V upon W. Therefore, we can write tan theta as V over W. Right, no? Right. If you don't use this method, people, the simplification is little bit long, right? Simplification is little bit long, right? Now, what I do to take this answer is this. 1 plus tan square theta sec square theta. 1 plus tan square theta is sec square theta. Right. Then we can write 1 here. For tan square theta, I can put this. Right. V squared over W squared. Sec square theta mean people. Cos theta we know When you take reciprocal of cos theta, we get sec square theta. Then what is the sec theta? V upon u, no? Then here we get v over u perfect squared. Right. Now, here we get v squared over u squared. No? We'll divide both sides by v squared. No? We get what? 1 over v squared plus 1 over w squared is equal to 1 over u squared. This way, we can take this answer. Right, no? Okay. Okay, the next part, VT graph. VT graph, right? Velocity time graph. Yeah, there you are given this way. Right. Shall I erase this? Okay, you are given a particle P is projected vertically upwards from a point O at a height simple h above the ground. Okay, like this. This is a point O. This is the ground. Point O is at height h. Right. Particle P is projected upwards with velocity u, suppose. At the same moment, another particle q is projected vertically downwards with the same velocity from the same point, q. Right? Q downward with velocity u. After time t, particle P attains its maximum height. Yeah, particle P attains its maximum height. Somewhere here, it is at the maximum height. You know, at the maximum height, its velocity is 0. The time taken to occur this is t. Right? At the same moment, particle q reaches the ground. Right. Particle q reaches the ground at the same moment. Therefore, this is also the same time taken, people. That's what this says. Okay? Right. Now, right? Now, what is asking there? Okay? Right. Then there you are given. After time t, particle P attains its maximum height and at the same moment, particle Q reaches the ground. Particle Q reaches the ground, right? What is asking then? Asking, draw velocity time graph for P and Q on the same diagram, right? You know, here P and Q are moving in opposite directions under gravity. Yeah? Then you should have, we draw velocity time graph. Velocity is a vector. Direction is important, right? So then we can draw the VT graph like this. Right. So A, time axis, Right, velocity axis I take here the velocity u, the particle p moving upwards under gravity with retardation g. Then its VT graph should be like this. This way. This angle theta, then you know tan theta is g. That g is the retardation g. Same moment, particle q is projected downwards. If we take the upwards velocity as positive, downward velocity should be negative. So that is starting this way, minus u, no? This way minus u. Then once the particle q moves downward, it accelerates, subject to the same g. Then the VT graph of q should be parallel to this way. The VT graph of this q and this p should be parallel each other like this, because move under gravity. This way, right? Right. Suppose time t is this, no? Right. So now the VT graph of q is this. Okay, no? Right. Then here people, if I construct this way horizontal line, this angle also theta. Reason, these two are parallel. Okay, these two are parallel. So this angle mean really when I produce this way, this angle, theta, no? By virtue of that angle, that's the here we have. Therefore, this is the motion of q. Right? Motion of p is this. I'll take this angle, this time as t, that given as t. Then the negative axis of the velocity is this, minus v axis. Right? I take this velocity as this way. When the particle q reaches the ground, I take the velocity as minus v. Right. Now, I take this as OA, B. And let us take this as C, D, and E. Right. This way, I can name them, right? T, tan theta, G. Okay, right. Now, we do the calculation like this. We need to show h equals 3 by 2 gt square. People, h means what? The height descended by q. That is given by here, this area. What area? O, C, D, B area is the h. Why? The motion of particle q, its VT graph is this red part from here to here. By this red VT graph, the area covered between the time axis and itself is this trapezium. Then the area of the trapezium should give the displacement traveled by the particle q. Since we are given the height is h from the ground for the point O, that OCD B area should be equal to simple h. That's the other data we know here. OCDB area is equal to h. Right. Now, I take like this, people. Calculation I am going to do like this. By this OAB triangle, by OAB triangle. We write tan theta. Opposite side U, adjacent side T, tan theta is G. Right. Use the cross multiplication. U equals GT. Secondly, people, by the triangle CDE, by CDE triangle, we can write tan theta. What? This side, opposite side, this height divided by this. Right. Now, people, here this minus signs with these velocities indicate the particle moves down, that moves downward. So therefore, the minus sign, we don't care about minus sign, that only reflects us, gives us the direction of motion of what? Particle Q. So therefore, when you write tan theta there, we ignore that minus signs. We think from here to here the height is V, from here to here the height is U, then this height DE going to be V minus U divided by this T. And then tan theta again G. Put that G here, V minus U by T. Right, people? Then use the cross multiplication like this. GT, bring this U to this side, plus U is equal to V. But we know this U is GT. Put that there. GT plus GT equals V. Then we get V as 2GT. Okay. V equals 2GT. Okay. Now I can write this area, OCDB area H. Right. OCDB area is equal to H. People, you know, this OCDB is a trapezium. Area of a trapezium, you know how to write. It is half sum of the parallel sides. This is U, this is V. They also don't take this minus. Minus means, of course, it says a direction. Right? It says a direction. Area is never be negative. That is always a positive quantity. Then U plus V, sum of the parallel sides. Here U, here V. Into perpendicular height. Equal H. Alright. Now substitute people for this. Half U. U is GT. Plus V, 2GT. Times T equals H. Now answer coming, no? GT, 2GT, 3GT squared by 2 is equal to H. This gives us H equals 3 by 2 GT squared is the answer. Right, no? This is how we take that answer. Right. Another two questions. Vector question is the next, number 7. Right. Number 7, relative to a vector origin O, this way, then Poisson vector is null vector, no? The Poisson vectors of the points A, B, C. All right, A, B, and C here. Here A, B, C. A has the Poisson vector 5 times simple A vector. 5A. Next one, 15B, Poisson vector of B. Next one, C, 24B minus 3A. Here are the Gaussian vectors of ABC points. I show that the points ABC are collinear. Right. ABC are collinear means the 3 points ABC should lie on the same line. That's what we need to prove. For this, what we do, people, we first write the AB vector. You know how to write the AB vector? AB vector when you write second letter Gaussian vector minus first letter Gaussian vector. Second letter is B, Gaussian vector is 15B. Minus first letter is A, 5A. What is this? Take this 5 out. 3B minus A. Correct, no? 3B minus A. Next one, AC vector we can write. Gaussian vector of C minus Gaussian vector of A. Gaussian vector of C is, people, 24B minus 3A minus vector of A, 5A. Right. What do you get there? 24B minus 8A. Take 8 out. 3B minus A. We get for what? AC vector. Okay? Right. Now I erase this all. Right, no? Yeah. Now I can write this AC vector here. Look at this. This 3B minus A vector. You can subject dividing this AB by 5. Can now write AB vector equals 5 times 3B minus A. Then I can write 3B minus A vector is equal to AB vector by 5. Now, what is our AC vector? Is no. It's for this 3B minus A, I substitute this AB by 5. Now, AC vector equals 8 times, right? 8 times 3B minus A here. 8 times 3B minus A. For that 3B minus A, people, I put AB vector by 5. Like this. Then we get AC vector is equal to 8 upon 5 AB vector. Now what do you have, people? Two vectors are equal. When two vectors are equal, you know the corresponding line segments, right, parallel. Number 1. Okay. AC line and AB line must be parallel. AC line here, A and C when we join, that line and A and B when we join. Right? Now both lines are starting from the point A. A to C line, A to B line should be parallel. In order to occur that, since the both lines are starting from the point A, this ABC must be collinear. So therefore, this says A, B, C are collinear. Right. Secondly, people, by this relation, what do you get? Second thing, when this way two vectors are equal, left magnitude is equal to right magnitude. Left magnitude is AC length. Right magnitude is 8 upon 5 AB length. Right. This is what we get by the second, by this equality of two vectors. Understood? Then we can write by this, therefore AC, bring this AB here, left hand side denominator, it is 8 by 5. Alright, now you can mark here A, here B, here C. When A to C, from here to here, 8 units, right? AB from here to here, 5 units. This is 5, this is 3. Correct, no? A to C, 8 units here. A to C, 8 units. 5 plus 3, 8 units. A to B should be 5. Then we get AB, BC ratio people, 5 by 3. This is what the second answer asking. 5 by 3. Correct, no? Okay. The last question, problem forces. Right. Okay, next one, given this way, a smooth hemispherical ball of radius simple A is fixed such that its rim is horizontal. Rim is horizontal. This way. I'll draw it here. Hemispherical ball. Right, people? Hemispherical ball. Huh? Its rim is horizontal. Right, this way. Right. Rod is resting. One end of the rod is in contact with the inner surface of the ball, and the point on the rod is in contact on the rim. Rim means, people, this edge. This is called as a rim. Okay. Then I draw it like this. Huh? Right. You know, the reaction coming here to the end of the rod by the hemisphere should pass to the center. And here, the reaction coming to the rod by the edge of the hemisphere, perpendicular to the rod. Therefore, we have learnt in our lesson, the line of action of the reaction here passing through the center, this end, this reaction which is perpendicular to the rod should meet where? At a point on the circumference of the what? Hemisphere. Like this. You see. R. This is S. Then the other force acting on the rod is its own weight. Finally, the rod is in equilibrium under the action of three forces. Therefore, the line of action of weight should pass to the point this. Why? We know when any object is in equilibrium under the action of three forces, we have learned that three forces must meet in a point. So therefore, the line of action of weight produced should pass through the point this, you see. This way. These are people that right. G. Weight is here. This is a uniform rod. Uniform rod. So therefore, this should be the midpoint. The G should be the midpoint of the rod. Suppose AB. Let this point be C. This is 2A. Right. Now, when we draw horizontal line here, that horizontal line should pass through the point this. The reasons you know, we have done this kind of questions. See the notes. This is 90. This angle 30. Given in the question. And we are given people, the rim is horizontal. That means this is the center. I mark by this dot. This is the center of the circle. This edge is horizontal. Then when I join this point and this point by a line, this line also horizontal. Then I am going to draw that here. Then this dotted line and this become horizontal. Therefore, if the angle this is 30, this should also be 30. Okay. Now, this is a radius. This is a radius. Then this side and this side equal. Then this angle and this angle should also be equal. This is the force diagram. This is people force diagram. Right? This is force diagram. Right now? I'm asking what length of the rod. This G is the midpoint. Center of gravity of a uniform rod is at the midpoint. Then this AG and GB are equal. Right. Then we can do the calculation like this. This length, I can write in two ways. If I take this AG length as X, this length is X cos 30. What length? From here to here, correct? No? Here to here, X. This is 30. Therefore, this is X cos 30. The same length I can write from here to here, 2A. This is 60. 2A cos 60. Right? Very simple when you use the geometry. Right. Then you can write by the diagram. We can write by the diagram. X cos 30 is equal to 2A cos 60. X cos 30 root 3 by 2. 2A cos 60 half. This and this you can cancel down. Then X comes as 2A divided by root 3. But the length of the rod means 2X, no? This is the midpoint, no? Then the length of the rod is 2X. Therefore, the length of the rod. X. X is 2A over root 3. This is 4A by root 3. Right. Is the length of the rod. Also find the length of the part of the rod projecting beyond the rim of the ball. Right. So that means this BC length asking to find. This here. This BC length we need to find. People, this BC length from here to here the length you can take. How? From this whole length of the rod, we'll subtract this AC. BC part we can write. BC part is equal to, people, AB part minus AC part. AB part only, the length of the rod just now we found 4A over root 3. Minus AC part mean from here to here, no? Here it's 90. From here to here it's 2A. This is T 30. Then this length is going to be 2A cos 30. 2A cos 30. We get BC 4A over root 3 minus 2A cos 30 means root 3 by 2. Then here we can cancel down this and this. Take this root 3 as the common denominator. This is 4A minus root 3 and root 3 is 3. 3 times A. 4A minus 3A is A over root 3 is that length. This is how we do. Right?